We are now going to discuss sugar alcohols. Sugar alcohols are produced by reducing the monosaccharides, the sugars. And then what happens is your body doesn't absorb them the same way as a regular sugar does, like glucose. And because of that, they don't have the caloric intake as well since they're not absorbed. And that's why you see a lot of them on the sugar-free packets. And that's why they also say 0 calories. So as we remember, monosaccharides can be oxidized by breaking that double bond. They can also be reduced. So if we look at this, here is the aldehyde with the oxygen double bond. Because of the double bonds already there, in order to increase the oxygens, we're going to put an oxygen in there. And that's how it becomes oxidized. Now fructose, even though there's a ketone here, can still be oxidized. The way this happens is actually it momentarily becomes an aldehyde. These two switch places. And it's a chemical process. You don't have to worry about the chemical process. You just have to understand that, yes, that's what happens. They switch places and it becomes an aldehyde. And then once it becomes an aldehyde, then it can oxidize because you have a hydrogen there. So when it's reduced, however, is when we have the aldehyde here first, and then it has the long chain of the OH groups. When we oxidize it, we add in the oxygen. When we reduce it, we're breaking this double bond, and we're adding a couple more hydrogens to it. Hopefully you remember that from the previous chapter. Now this is what doesn't get absorbed into our system, which is why we use it in sugar-free packs. So technically, extra is sugar-free gum because they've taken glucose and they've reduced it by adding those 2 extra hydrogens up here. And now it's called sorbitol or glucatol, but commonly sorbitol. It's right here. And it still gives it the sweet flavor, you just don't absorb it into your system, so therefore you don't have the calories. It's still somewhat controversial, so it's not 100%, and they can't decide whether or not to consider it a carb, but it does not absorb into your system, so that's why you don't have the calories. So, if we look at the oxidation and reduction of this particular compound, if it oxidizes, we're going to add an oxygen into the hydrogen spot. So carbon, 1, 2, 3, 4, 5. Then the 6th one is down here. And the rest of these are hydrogens. Alright, so all of this is the same. When we oxidize it, the double bond remains, but instead of that H, it's now OH. When we reduce it, we're going to do the same thing. So there's our first carbon. 1, 2, 3, 4, 5. Then the 6th one is down here. Space those out pretty bad, but that's okay. And the rest of these are hydrogens. So when we reduce it, we're adding hydrogens rather than oxygen. So that means this double bond is going to break. That hydrogen is still there. That double bond breaks to form OH, and we're going to add another hydrogen in addition to that. And that's your alcohol. So we're into the reduction. We added another hydrogen and an OH group. So here's the original hydrogen. We had a second one put in an OH group. So we actually had 2 total. With oxidation, we add in that extra oxygen. And that is the end of the oxidation and reduction of simple sugars.